hopefully we're in that carnival. Know where I am now. Hopefully we are working on right angle triangles part B. We're going to look at some more questions involving right angle triangles where we're trying to find a missing angle or a missing length. This first one, I'm writing the whole thing down. The next one, I'm just going to read it because they take forever to write down. And you can always look at the question anyway. So in this story, what we have, move this over here, right? What we have here is that the angle of elevation to the top of a very tall building is 8 degrees, and that's from the ground at a distance of 1 mile. And then they ask us to find the height of the building. So I need pictures. I think most people do. So there's the ground, there's the person, and there's the tall building. And when they say the angle of elevation, they mean if you look at horizontal, how many degrees do you need to move like upwards to see it? And the answer that they gave us is that that is 8 degrees. And vertical meeting the ground is always going to be a right angle. And the distance from here to here is 1 mile. Are you all comfortable about that written description matches this picture and how I did it, right? And we are being asked to find how tall the building is. So since you're going to ask me to find that guy, I'll call it X. And do I have my little list here? I do, good. Thought I'd thrown this away. You know we're going to use Sohcahtoa. In fact, aren't we just going to use the first 3 guys in Sohcahtoa typically, right? One of these 3. So I've got my right angle triangle. This side here, which is the height of the building, is the opposite. And this distance here is going to be called adjacent. And those are the only 2 I'm interested in, right? So which one of these guys over here uses those 2?
Tangent.
Okay, so I can set up our relationship, which is the tangent of 8 degrees is the opposite over the adjacent. And the tangent of 8 degrees is going to be x over 1. And if I do a little cross multiply, we got one of the lucky ones. I mean, all the numbers come out really good. And x ends up being, make sure I'm in degrees, which I am. And all I need to do is find what the tan of 8 degrees is. And this is not the final answer. It is 0.14054 and some other stuff, right? And the reason it's not the answer they want is that this is how tall it is in miles, right? Because the units were miles. They want to find the height of the building in feet. So I'll move this up a touch. If you want to convert 0.14054 into feet, what's that magic 5,000 number that you need to use to do that?
5280.
Right. That's happened a few times, hasn't it? You know, you needed to use that 5280 thing. So I'm going to go 0.14054. I'm going to multiply it by 5280. And to the nearest whole number, I get 742, but now the units are in feet. Are we comfortable with that answer? So let me show you just little fiddly things that you could do wrong.
I have a question.
Yes, what's your question first?
Why didn't you convert the miles into feet at the start?
No reason at all it would work. It would have worked. You'd be perfectly correct. And you'd still get the answer. So nothing wrong with it. I just choose not to. That's all.
Okay.
There's no real reason. Now, suppose I decided to only use 0.14. And then I multiply it by 52,800. Can you see that my answer is now 739? Now, isn't the difference between the answer that I got here and the answer I got here just a matter of accuracy? And you know, WebAssign is kind of fussy, isn't it? If that's the number it wanted, giving me this one, it might tell you that you're wrong. And it's not that you did anything wrong, isn't it? Just an accuracy. So a kind of suggestion here is that when you're doing questions involving any kind of accuracy, always do all the in-between calculations. So that's an in-between calculation to a lot more decimal places than even you feel you need to. And only round off right at the end, right? So at this point here, that's when I round off the nearest whole number. Now, if you converted that into 5 to 80, you would have got, well, you'd end up with the same calculation, right? So make sure that you do that as accurate as you can. Very often you can just let the calculator do it, right? Just leave the number that tan of 8 is, and then just multiply it by what you need. Okay, are we good with that question? Now, next one is got a lot of reading and stuff, and I'm not writing it down as I said. So I'm just going to create the picture as I read it. So this is a version of 23, which is to do with an aircraft flying over St. Louis, the Gateway Arch in St. Louis. Is the Gateway Arch that thing that looks like 2 elephant tusks? You know the thing I'm trying to describe? Is that the one that's in St. Louis? No. Anyway, there's something that looks like a big cat, big tusks to me. Back to the story. Here's the ground. There is an aircraft. There's my aircraft. And it's flying at an elevation of 30,000 feet. So you've just told me that distance, right? And over here, we've got that archway, whatever it ends up looking like. And the pilot would like to estimate the distance from his aircraft to this archway. And where is the information then? Okay. She finds that the angle of depression to the point on the ground. So to that point there, the angle of depression. So can you imagine it's coming down like that? Now, to get the angle of depression, it's a little bit messier. You imagine an invisible horizontal line. That is the angle of depression. So you're looking horizontal, and then how many degrees do you look down to see the thing? And in this case, the angle of depression happens to be 19 degrees. And they want us to find 2 different things. First thing, they want to find the distance between the plane and the base of the arch. So they want us to find the distance from here to here, right? And I'm going to call that guy X. So find the distance from the plane to the ground is find X. Right, a couple of little bits and pieces to add on here. Would you agree that that's the right angle? Now, I am going to be using a right angle triangle. It's going to be this guy over here. Little baby version of him. This side here is 30,000. I want to find this side here, X. What is that angle there? Because it is not 19. This is 19, but what's that guy?
71.
Are you all comfortable about where the 71 came from? Have you noticed that when it's angle of elevation, you tend to use the number that they give you? But when it's an angle of depression, you tend not to use that number, don't you? Tend to use what's left from 9. So now that I've got this guy set up, from the angle 71's perspective, what name do you give to the 30,000 side?
Opposite.
Is it the opposite from angle 71's perspective?
No, it should be the adjacent.
Right. Don't have a lot of room here, so I'm going to just call it A. Are you comfortable that X is the hypotenuse? Right. So we're going to use an adjacent and an hypotenuse combination. So over here, there should be an adjacent and hypotenuse combination, isn't there? So which one is it?
It's cosine.
Agreed. So the cosine of 71 degrees is the adjacent over the hypotenuse. So the cosine of 71 degrees is 30,000 divided by x. Then we'll do the little cross multiply and we get x times the cosine of 71 degrees is 30,000. And x is, I'll divide both sides by the cosine of 71. So go to your calculator and we do 30, 1, 2, 3, divided by a cosine of 71. And the answer, oh, what do they want the answers to? Oh, to the nearest whole number of feet. So I am looking at 92,147, because that rounds up to 7 feet. Are we comfortable with that? 92,000 feet away. It's, it's quite a few miles away, right? Almost 20 miles away, I think. So far, so good. Right now, since I know that number, I'm going to write it into my little picture. 92,147. And question B asks, what is the distance between the point on the ground directly below the aircraft, which is here, and the base, which is here? And I'm going to call that guy, no particular reason. Why? If you want to see what that triangle would look like without too many distractions, we have quite a lot of information here, right? That's what that triangle looks like now. Would you agree? I'm going to pause for a minute. There we go. Return back. There are two totally different methods I can use to find y. Both of them will work. So it's not like there's only one right way to do it. Can someone tell me just the method that they might use to find missing side y?
Tangent.
That does. You could certainly use the SOHCAHTOA of the tangent, correct? And what's the other method?
Pythagoras theorem.
Pythagoras, right? So do you want me to finish this one using Pythagoras, or do you want me to finish it doing one of the SOHCAHTOAs? How do you want to see this one done? They're both correct and they both get the same answer. What do you want?
I started doing the Pythagorean, but the numbers are ridiculously big.
So you've changed your mind and you don't want to do the Pythagoras anymore, right?
Probably not.
Okay, then we'll do one of the others. From 71 degrees perspective, this side is called the adjacent. Sorry, bring this back to front. This is called the opposite. This is the adjacent, and this is the hypotenuse. And actually, we have got an overpreponderance of things we can use. I need to use that, right? Because I want to find y. Now, if I decide to use that one and the 30,000, won't that be a tangent? Opposite, adjacent. If I use this one and that one, won't I be doing a sine? So guess what? There's two versions of getting the right answer here as well. Won't matter. They're both going to be the same answer when we're finished. So let's do a sine, okay? So I'm going to say that the sine of 71 degrees is the opposite over the hypotenuse. And so the sine of 71 degrees is going to be y over 92,147. And if you do a little cross multiply, you get the nice one, because it's just y is 92,147 times the sine of 71 degrees. And into the calculator, 92,147 times the sine of 71. And I'm looking at 87,127.
I have a question.
Yes,
So since we rounded off for the 92,147, it's one off compared to if I use the 30,000, which was like the set number.
that is very interesting and also correct.
Yeah, because when I
If I-
used tangent, I used 30,000. I got one less than that.
Yeah.
Correct. And guess what the correct answer is in Weber sine? That one.
26.
So just be careful of rounding off, right? I used that number. If I'd used the 92,146.622, right, whatever it was, I bet you I would have got the same answer as you. So just be careful.
I never round any of my variables
You
until
just don't until the end.
Mhm.
Best idea. Just don't round anything until it's the last answer, right? I think that's the safest way of making sure that you're going to be exactly where Weber sine is expecting you to be. That was a good point. I didn't realize that until I looked at the answer, which I have in front of me, that I was one out. And now I know why. Oh, this question is really quite weird. 24. A laser beam is directed towards the center of the moon. Okay, so here is here, and here is the center of the moon, and it's to be directed to the center of the moon. So I guess I'll put labels. There's the moon. Here's somebody on the surface of the earth. But the beam strays 0.6 of a degree from its intended path. Oh. So it's meant to go, but it didn't quite do it. This angle in here is a tiny 0.6 degrees. Now the distance to the moon, we'll assume that that's the moon. Here, go along the way. The distance to the moon is 240,000 miles. How far has the beam diverged from its original distance? So maybe short of something. So what are they? Oh, from its original distance. Oh. I'll make that distance there. Okay. So my picture is a mess. So I'm going to draw it not to scale. That's what the picture should have looked like if I just made my life much easier. This angle here is that guy. That distance is 24,000. We are being asked to find out. That's where it should have been. That's where it did end up point, right? So from this angle's perspective, this side here, the one we need to find, this distance, is going to be the opposite. And the distance to the moon is the hypotenuse. And that means that I can now use the guy that uses that combination, which is the sine. So the sine of 0.6 degrees is the opposite over the hypotenuse. the sine of 0.6 degrees is x over 200. It's not 24, it's 240,000. Okay, fix that. So
I
a
have a
little
question
cross.
for you.
Yes.
How come you're able to do that? Because that's 6 degrees when it meets up with the original height. It's not a 90-degree angle.
I'm rearranging the way I'm imagining it. I'm imagining that that is one pointing at the moon, and then I'm imagining I'm just going up that way. So my picture would be like this. Right. Here is the Earth, and here is the moon. And then I'm going to be 0.6% out. Oh, I actually like that picture better. Let me finish this one, then I'll go back to that one. Setting up the picture was what is causing me all this grief. I get a feeling that's going to be a better answer, but let's find out. X is going to be this guy times the sine of 0.6. Let's see if that is the correct answer, which should be 2,500 miles. Oh, guess what? This one is right. So what's wrong with that one? Because that one looks like it could be right. Okay, let's try this one. This is going to be called the opposite. This is going to be called the adjacent. So if I was using this one, the tangent of 0.6 would be the opposite over the adjacent.
Doesn't the 240,000 have to be on the hypotenuse? Like,
Oh, good. So it's the same question, same answer. Everybody's happy. Right. If I had drawn the Earth here and the moon here, and I made that guy, right, and then, well, that can be the laser and that can be the moon, and we can make this 0.06, and you do this as 240,000. That should have been my picture. Well, God, that was more work than it should have been. So the question was, how far off would you be? Well, the units aren't even feet. It's actually miles. You'd be 2,500 miles out. And in question B, they tell you that, do you know the radius of the moon is only 1,000 miles? If you're 2,500 miles off, would you even hit the moon? And the answer is no, you wouldn't. So do you know those guys who flew to the moon? I think it was in 1969, right? The first time. If they had only been 0.6 of a degree out, now, can you imagine a protractor, what 0.6 of a degree looks like? You wouldn't even notice it, right? They would have missed the moon totally, right? They would just went, whoa, what was that? So the accuracy that they must have been using to actually successfully, not just land on the moon, but land on the bit of the moon that they actually intended to land on, right? There's a certain place on the moon that they wanted to do. Can you imagine how much accuracy they would need to be that good, right? That was pretty amazing by those guys. Okay, we got a couple more of these guys to do. I'm not quite sure which ones I want to do. That one's fine. Oh, let's do this one. This is 27. And we got a person, and they're on a hill. And there's a flagpole here. And we are given a whole load of information, but they also give us a picture which helps. The angle of elevation, right, so that line there with the horizontal is 18 degrees. And to the bottom of it, the angle of depression is 14 degrees. We're also told that the flagpole is 35 feet tall. And our job is to find that distance. Actually, I'm going to make that the last question for today on this section, because I want to spend some time getting ready for the next one. Have we got any suggestions about how to tackle this question?
Solve for the opposite of angle 40 first, or 14.
So if I'm picking up right, if I put some more solid lines in, the opposite of that is the size of this angle, and the size of this angle would be what, 76?
No, I meant, sorry, the side, like the opposite side.
Right, this side, or that one? Bottom, middle, or top? Which one are you talking about?
The middle.
Okay, so,
The middle.
oh, that's X, right? X is the middle. I got
No, okay, not that. On the flagpole itself.
you. Okay. So what do you want me to do?
Solve for that.
Well, we know the flagpole's 35, right?
Mm-hmm.
So how am I going to kind of work this out? That's going to be the problem. I'm not quite sure I've got a direction yet. You
about to
might
say,
have a good idea, but I'm not sure where you're going yet.
Oh, you don't have any of the other sides. Yeah.
Yeah.
I feel like you could just add the two 14 and 18 together and then find, using the 35, find the length of the one at the top, and then use 18 and the length of the top to find that middle line.
But I think it has to be right angle.
Yeah, but all we know is that these are right angles, and that's 76 and 14. I could do that one there, but that's not actually going to help us.
No, I'm saying you, I feel like I'm looking at it as like a huge triangle. So you could add 14 and 18 together,
Right? You
And
could
use that
certainly
angle.
do that. Uh-huh.
and the 35 degrees will be the opposite. Use, don't know which one that would be to find the adjacent of that, which will be the line at the top.
Okay, right, I got you now.
And then use that to find the middle line.
That's not going to be able to work. And the
Oh,
reason
no.
that's not going to work is because the big triangle is not right angled. Right, that's the problem. The big triangle is not right angled. If it had been, we could do that, but we're not going to. Okay, yeah, I'll take a bash at it. I'm going to find
Could
that
you,
distance there. Okay, so I'm just going to find this distance here. Right, and that distance is going to be on this triangle. So I've got a right angle triangle, this top piece. This is 18. I don't know who this is, and I'm going to find this guy over here, and I'm going to call this guy Y. And the first thing you're going to say, well, is I won't be able to get a number. And you're right, but that's not where I'm kind of going right now. I'm just going to find out what this guy is, right? This distance. So this is going to be opposite. This is going to be adjacent. And so the tangent of 18 degrees is going to be Y over X. And that makes Y the tan of 18 degrees X. Are you okay with Y being this guy? Doesn't look like I'm doing anything useful, but that distance there is the tan of 18 degrees times x. Great. Now, I'm going to look at the bottom and do a similar thing. I'm going to call that, I guess, Z. So I'm going to be looking at a triangle that looks something like this. 14 degrees goes here. And this is still x. So I have an opposite and I have an adjacent. And in this case, then, the tangent of 14 degrees is going to be z over x, and a little cross multiply, z equals the tan of 14 degrees x. Now, I know the goal of this question is to find x. It doesn't look like I'm going anywhere useful, but I am. I mean, this is going somewhere. What do you know about, what do you know about y add z? Well, isn't y add z 35? Isn't that the total height of the flagpole, right? This bit is y, that bit z, y plus z is 35. That means the tan of 18 degrees x plus the tan of 14 degrees x is equal to 35. You still with me, guys? What do you think is going to happen next?
You can divide an x out of everything.
Let's pull it out then.
Yeah. So you factor it.
Okay, good idea. So how will I get x then? What will I do to both sides to find x?
And then you just divide the tan 18 plus the tan 14, divide that by 35. So 35 divided by all of that.
Now, since that's the last puzzle one, do you see that was a kind of weird solution, but it worked. So let's find out what we have here. 35 divided by, make sure I put a bracket around it, the tangent of 18 plus the tangent of 14. And the answer is 60.9 to 1 decimal place. And that's actually correct. So that last question, the flagpole question, because there wasn't any big right angle triangle, what we had is two little triangles stuck together, but they'd never made a big right angle triangle. Didn't we have to do a kind of a kind of sneaky way to find it? I tried to find that guy, and all I could do is find out that it was a multiple of x. I tried to find this second piece, z, but all I could do is find out it was a multiple of x. And then I know if you add them together, it was 35. And then I basically just did, as long as you do it to both sides, it's okay. And eventually I could find out what x would be. I like that question because it is really different in a lot of ways to any of the others we've ever done. Really cool question. I like it. And question 28, right, is another angle of elevation, angle of depression question, but nowhere near as bad as that one was. Right, let's, well, are we finished with that? Is there any questions, anything you want me to go over? Okay, that's a thinking question. Let's look at our last section for this week. We're going to do, let's try that again. We're now on to section 6.3, and it's called trig functions. Using right angle triangles. Okay, I wanted to kind of get started in this so we can do a little bit of skill building before we kind of tackle the main questions tomorrow in this section. But the kind of things I'm going to do, some of which we know, so I'm kind of basically doing revision, and other things we're just going to look at them in a different way than we have in the past. Hopefully you can remember the 4 quadrants, right? And can you remember all sine, tan, and cos? What that did is, didn't it tell you whether a sine function or a cosine function, where they were positive, right, and where they are negative, right? So off the top of my head, if I said to you, I want to find the sine of an angle theta, and I tell you that theta is in the 3rd quadrant, will the sine of theta be positive or will it be negative?
Negative.
Right. In the 3rd quadrant, isn't the tangent the only positive one? That's how you read this, right? Tangent is positive in the 3rd. Everybody else is negative. Right. If I went and said to you, I want to find the cosine of theta, and I'm telling you that theta was, say, in the 4th quadrant, would the answer be positive or negative?
Positive.
Positive. You can also do it for, say, the cosecant of theta. Is the cosecant of theta positive or negative in the 2nd quadrant?
Positive.
Okay. A cosecant is 1 over the sine. And in the 2nd quadrant, the sine is positive. So won't 1 over the sine also be positive? So you were right. Okay. Now, as I say, would you agree that's just revision, right? We've done that thing before. Okay. Now, another thing which is also revision is if I tell you that the sine of theta was 3/4, can't we find the other 5 ratios? Right. So you would build a right angle triangle. Probably call that guy theta. You then name the sides from that angle's perspective: opposite, adjacent, hypotenuse. Since it's a sine that we're dealing with, we know that the sine is the opposite over the hypotenuse, in which case that guy is 3 and that guy is 4. And how do we find the 3rd missing side? Because we need it.
Pythagorean theorem.
Okay, and can you take my word for it? It's 16 take away 9, which is 7. So it's a square root of 7, right? So far, so good. We've done things like this before. Right, this is now, if you wanted to find, for instance, the cosine of theta, you would do adjacent over the hypotenuse. Well, the adjacent is the square root of 7 over 4. If you wanted to do, say, the cotangent of theta, well, I don't have the other 3 here, but isn't the cotangent of theta just this guy upside down? So it would be that one. And the adjacent is root 7, and the opposite is 3. And couldn't I do the others as well? That is also things we've covered. So what is the new guy in town? We're going to use right angle triangles to find all the missing trig ratios. But the difference here is that the angle is now going to be in any of the quadrants, right? So we can actually use it for 99 degrees and 250 degrees. Now you can't build a right angle triangle with 99 degrees, agreed, because there's only so many angles you can do, right? And the other two add up to less than that. So you're not going to get it. But we do an adaptation. We combine what quadrant we're in with this triangle. I'll show you how it works. Suppose I tell you that the sine of theta is negative 3/4. And I tell you that theta, right, is in the third quadrant, because it could be in the fourth, but I'm telling you it's in the third, right? How can I use that along with that to find all 6 trig ratios? So that's the new question. How do you find the sines and cosines, right, of values of angles that are not in the first quadrant, right? This angle, for instance, is definitely not in the first, it's in the third quadrant. Well, you build a right angle triangle. And you totally ignore the fact that that says negative anything. You just think of it as 3/4. And since it is 3/4, actually, maybe I should have chosen new numbers, but too late now. And can you see that you basically get an exact copy of the one I did a few moments ago? Right? You get the same triangle. And 3, 4, and √7. Now you notice that none of these have negatives in them, because it would be silly to say a side was negative √7, right? We don't do that. Now we know the angle is in the third quadrant. That's going to come out in a few minutes. So here we go. Once you've built this right angle triangle, let's suppose I'm interested in finding the cosine. Well, that's going to be the adjacent over the hypotenuse. That's not a big deal. The adjacent is √7 and the hypotenuse is 4. And then this guy comes into play. If the angle is in the third quadrant, will the cosine be positive or negative? If your angle is in the third quadrant, will the cosine be positive or negative?
Negative.
And that means that is the adaptation. So do you see it's only a little minor adaptation? It's the same numbers, the same fractions, the same right angle triangle, you know, the same formula. Is it the difference going to be some of your answers are going to be negative, right? And some are going to be positive, because when the angle is in the third quadrant, it's not the same as when it's in the fourth, right?
Sorry, I had a quick question.
Yes.
Is it supposed to be like that, or is the adjacent and the opposite sort of mixed up where the triangle is supposed to be, or is that how that's supposed to look in the third quadrant?
Yeah, you just have to 3, 4, 3, 4. So what you're saying is this triangle mixed up? Are you thinking I should be drawing it in a slightly different orientation?
Yeah, I don't know. The adjacent looks like it should be the opposite, but that might just be me.
Oh, here? From this angle's perspective, that is the adjacent, right? You're right next to the angle. And this is definitely the opposite. So,
Okay, thank you.
okay. Right. Suppose I wanted to find the tangent of theta. Well, that's the opposite over the adjacent. And that's 3 over the √7. Again, you ask yourself one question, is it plus or minus? And they get the answer by saying, okay, what is a tangent going to be in the third quadrant? Positive or negative?
Positive.
Positive.
Good. Positive. So we're done. Well, yeah, we're done. But if you want to make it look pretty, I guess you could do that. But it's still positive no matter which way I write it. If you wanted to do a cotangent of theta, and you've already found this guy, right? Isn't the cotangent just turn me upside down? I don't need to worry about plus or minus, because won't the tangent and the cotangent both be the same thing, right? If one of them's positive, so will the other one be, right? If the tangent's negative, so will the cotangent. And that's essentially how we extend SOHCAHTOA, or at least the formulas like this, to allow us to be given one piece of information and an angle. And that's all you need with a little bit of SOHCAHTOA and right angle triangles to find all 6 trig ratios for any given circumstance. That's pretty clever, isn't it? It's what you've done, just add a little plus minus to it. And perfect timing. I'm getting better at this timing thing.
Yep.
Okay. What time should you always go to the dentist at?
2:30.
Yep. 2:30. Oh, God. You lot depress me sometimes. That is a good joke. It's a very old joke and everybody has heard it, but it's still a
I
good
didn't
joke.
get it for a second. I didn't realize that it was a joke. Yeah, but yeah, it is good.
Okay. Well, this is a saying my wife likes to do, especially when I'm ranting on about things. She says, "You're living in Egypt." And I say, "What do you mean I'm living in Egypt?" She says, "You're living in denial."
Yeah, that's a good one.
The night denial. I'm going to take a picture of you, Anita, when I tell jokes, because all I get is, "What? That's meant to be funny?" God, yeah. Right, have a nice day, everybody. I will be hanging about for some
Hey, Katie,
questions.
nice shirt.
Thanks.
Oh, okay.
Look at it.
Evidently, I'm not allowed to comment on things like that, but it is a nice shirt.
I had a quick question.
Yes.
On the homework for part 1 of 6.2, there was a question on my number 6. And
Okay, and I'm going to find it. If you can just hold on, that way I'll know what your numbers are in case they change, because they do. Okay. It looks like it could only be the only question because everything else looks right.
yeah,
So it was question number 8. Is that right?
8 and number 6. I had those 2 questions. I know
Okay,
that
6 you got right, but you're not sure why?
well, no, I know why. I just
Okay.
I used special right triangles because when I didn't use it, it
You
wasn't
couldn't
right.
get it to work. Okay, so you want to see how you do it without
With-
using special ones.
Yeah.
Okay, let's do that one first.
Not to, but I was like, well, it's easy.
Okay. So, in question 6, you're given a right angle triangle that's kind of orientated like this. There's the right angle up here. This is the angle that's 60 degrees. You're told that this is 2 and you're asked to find x. Agreed?
Yes, I got that.
Okay, so naming the sides. This fella here is the hypotenuse, and this guy over here is the opposite. So far, so good?
Yep.
So if we are going to set up which of the SOHCAHTOAs to use, it's going to be a sine, because that's the opposite over the hypotenuse. Agreed?
Yeah.
And so the sine of 60, I believe, is √3/2 from my unit circle. And it's going to be x over 2. So when I do my cross multiply, I get 2x is 2 square root of 3. And if I divide both sides by 2, there's the √3 that you got.
Oh, so you take the sine 60 from the
Unit circle.
Unit circle. Okay.
So if you ever get a question and they don't say to 2 decimal places, that must mean that the angle is in the unit circle. So use the unit circle's value in your calculation, and that way you'll get an exact value. Okay. And the other question you had was 8, which I'm
Yeah,
going to have to be.
I really couldn't get that. I don't know why.
Right.
I don't know if I explained it or not, but
I don't recollect explaining this one. So there's theta. The sides are kind of arbitrary, right? They're called X, Y, and A. But from this angle's perspective, this is opposite, this is adjacent, and this fellow over here is hypotenuse.
yeah.
Now, question A says, express X in terms of a trig ratio, right?
Yes.
And there's 2 correct answers to that, but here, I'm going to pick that guy and that guy, right?
Mm-hmm.
So the sine of theta is the opposite over the hypotenuse.
Mm-hmm.
And if I do a little cross multiply, I get y sine theta is equal to x,
That's what I got.
which is what you got. Now, of course, I picked the wrong one, evidently, because according to them, I should have picked the one with a tan in it. Oh, A is 4, by the way. Okay, right, so according to them, I should have picked those 2 guys. So the tan of theta is x, right? Opposite over adjacent, which is 4. And when you do your thing, you get 4 tan theta. Now, why is that better than the answer that we gave? Well, it has one number in it, right? And that's why they picked it.
Okay, yeah. So it'd be x equals 4 tan theta.
Yeah,
Okay, and that's what they got too.
that's what they got. And the other one they want is y, right?
So
This
you
guy
just
up here.
do cosine.
So I would, yeah, you do a cosine. Some weird terms, so let me show you. If you do the cosine of theta, you get 4 over y. If you do the cross multiply, you get 4 cosine theta, right? That guy equals 4, I should say. And y ends up being 4 over the cosine of theta,
Yep.
which is correct. And it might accept it. But the answer I can see is 4 secant theta. Because isn't 1 over a cosine also a secant? So that's